Hello everyone, my name is Emanuele Giuseppe Esposito, and in this demo I will show you how to run a confidential AI workload using confidential containers and Nvidia confidential GPUs. Let's start with the problem description. Let's assume we have our workload, an AI pod in this case, which is deployed in our application platform, for example Kubernetes, running on our favorite platform provider. What are the two main attack vectors that are important for this workload? Direct access to memory. A malicious actor can try to access data and secrets while being used, so while they are in memory. Manipulate hardware and software. A malicious actor can try to add a spyware, disable security mechanisms in the platform or infrastructure, and so on. Let's see who are the malicious actors here. Platform admin. He has privileged access to the application and to the platform, so he can try reading secrets. Pod software. The software itself that runs the application might try to send confidential data elsewhere. Platform provider admin. He has privileged access to the infrastructure, so he can even try access the hardware and dump memory content while secrets and data are being used. And to conclude, the platform provider software, which might be hacked to fetch applications memory and send it somewhere else. To prevent data to be accessed while running, the idea is to run a containerized application in a confidential virtual machine, also known as CVM. This is a virtual machine that is not running in the application platform, but it's connected to it, running in the same platform provider. As we will see later, we will use the peer-pods technology to automatically create the confidential virtual machine and connect it with the application platform. We call it confidential because it also leverages hardware trusted execution environments, such called TEE, to enforce memory protection, and if application leverages the use of GPUs, there is also the possibility of using confidential GPUs to protect the data running in them too. Therefore, the platform admin cannot log into the pod CVM because it is disabled in confidential containers. If the provider admin tries to physically or virtually dump the confidential virtual machine memory, it will also get nothing, as the memory is encrypted by the trusted execution environment. If the provider admin tries to log into the pod or confidential virtual machine, access to that, for example SSH, is also disallowed. And to conclude, if any of the malicious actors tries to change the confidential virtual machine software or hardware, we perform what is referred as attestation to make sure that software and hardware has not been compromised. In addition, the attestation service can also provide secrets to the confidential virtual machine only if attestation is successful, to make sure they are only used in a secure environment. Let's move to the high-level setup. In this scenario, we are fully deploying in the cloud. The public cloud provider is equipped to provide virtual machine instances that run with the hardware trusted execution environment. In addition to that, for this demo, we also require that these instances are equipped with the confidential GPUs, such as the Nvidia H100 models. Using the peer-pods technology offered by Openshift sandboxed containers operator, we are able to create a confidential virtual machine that will not run in the worker node, which is not equipped with the confidential hardware, but in a separate instance equipped with both trusted execution environment and confidential GPUs. Inside our confidential virtual machine, together with the OS, we will have some additional components like the Trustee agents that, as we will see later, are necessary to connect with the Trustee operator. And in addition to that, we of course have our confidential container workload, in this case coming from Openshift AI. To increase security, the model that we want to run in our confidential container is encrypted. But how can we decrypt it and where is the key? The solution is in the Trustee operator, which runs in a separate, secure environment, not in the same Openshift cluster. The Trustee job is to perform attestation, which means getting the software and hardware measurements coming from the confidential virtual machine and compare them with a set of expected results, called reference values, that have been set in the Trustee beforehand. This is how it works. The Trustee agents collect measurement from the CPU and the OS software, but also from the GPU and its drivers, to make sure that the whole setup has not been altered and the hardware effectively encrypts the memory to prevent anyone from reading it. The measurements are then collected in what is called as attestation report, and then the report is sent to the Trustee. The Trustee internal component then analyzes it, comparing with the reference values. And if it's the same, attestation is successful. This means that the secret associated with this request, in this case the model decryption key, can be released and sent back to the Trustee agents, which in turn will give it to the container, which will have the logic to then use the key and decrypt the model. Let's now look at a practical demo. But first of all, let's look at the various products and companies involved in this example. First of all, the public cloud provider is Azure, which provides instances with confidential CPUs and GPUs. Then, the trusted execution environment, the confidential CPUs, are in general coming from Intel or AMD. In this instance, Azure offers AMD CPUs for the GPU instance we are going to use. The GPUs in this Azure instance are Nvidia H100 confidential GPUs. Of course, our platform is the Red Hat Openshift. And the Openshift sandboxed containers operator offers the peer-pods technology to create and manage confidential containers, which are running on Azure instance using the confidential hardware. Then we have the Trustee operator, also available in Openshift. And to conclude, the workload is provided by the Openshift AI. For this example, we are focusing on the model serving part, in other words, AI model inferencing. The model we picked with this example is FLAN T5 small. We picked that because it is a large language model. It is also small enough to run with CPUs for comparison, but also take advantages of GPUs when available. It is publicly available on Hugging Faces, so no model development required. Let's look at the workflow assumptions. First of all, we are just focusing on inference this time. Therefore, we assume that the first part of the model lifecycle, development and training, is done in a user-secure environment. Then, usually, the finished model is uploaded into a S3 storage to be available for the inference part. In this example, we use a mini pod to simulate S3 storage, and we also assume it is running in a user-secure environment. For the third part, inference, we change the environment. We will run it in the public cloud, so the platform provider is not trusted. At this time, the model is simply downloaded and then run. So one step to increase security would be to encrypt the model, starting from the development, and upload it to the mini pod as already encrypted. The model will then arrive in the inference pod and only there decrypted. But then where is the model key? If the answer is in the model or in the platform node, then it is not good. Any platform provider or system administrator would have access to the memory of the platform and get the key and therefore the model. Therefore, the solution is to firstly run the model in a confidential virtual machine, supported by the hardware trusted execution environment and confidential GPUs. And then also add the Trustee attestation, which provides the key to the container to decrypt the model only if attestation, therefore hardware and software are not compromised, is successful. Let's first look at the Openshift setup on Azure. In this setup, we created an Openshift self-managed cluster on Azure. This cluster is composed by a single master node and a single worker node. Inside the cluster, we installed the following operators. Red Hat Openshift AI, together with the Openshift serverless and service mesh operators, to make sure we can develop, train, and deploy AI models on Openshift. And then the Openshift sandboxed containers operator to create and manage confidential containers. In a separate Openshift cluster running on a trusted environment, we installed the confidential compute attestation operator, also known as Trustee. This operator will take care of performing attestation and provide secrets, in this case a decryption key, to the confidential container only if attestation is successful. If we look inside the attestation operator, also known as Trustee, we will see that it's already configured and running. The important setting here is that I created a secret called KBS-RES1, and inside this secret I added a key. This key will be provided to the confidential container only if attestation is successful. The key will be used to decrypt the incoming encrypted model. It is now time to train and encrypt the model. Let's look into the Openshift AI web UI. We can see that I already created a project and called it LLM, and inside the project I already created a workbench. In addition to that, I also set up a mini pod which will act as S3 bucket storage. I also already configured it to run with the Openshift AI. Let's look what happens in our workbench. First step is to download and save the model. I chose to download a Flan T5 small AI model from Hugging Face. The additional step required for confidential containers is to encrypt this model. For simplicity, I first compressed the model and then I encrypted it using a fence program that I provided together with the key. Note that in this case, the key is allowed to be here because the training and uploading the model is run in a trusted environment local to the user. Therefore, it is safe to have a key. I then proceed to delete the original model together with the key. Later, I decide to upload the model as encrypted file to the S3 bucket. We can see here that has been uploaded. For the first example, let's do inference with the traditional pods, so the one created by default by the Openshift AI. Let's now look at the model section inside our project. We can see that I created two model servers, but for now we will only look at the run C one. This model server will run as a traditional Openshift AI pod. Therefore, it will run in the Openshift worker node. This pod performs two steps. First of all, download the model from the S3 bucket, and second, run it. We can see inside the pod that it downloaded the plain text model, because this is not a confidential container, and then that it ran. I also added some logic to show if the model is running on CPU or GPU. Note that this model can run in both environments. Inside our workbench, we can also try and check if the model works. In this case, I already configured an example snippet that basically connects with the model and perform an infinite amount of requests, counting how many responses it receives. we can see in the bottom that the model is not really fast because it's also running only on CPU. And to conclude, let's perform inference with confidential containers. Let's now look at the other model server, Coco. This model server is running as a confidential container. This means that it won't run inside the worker node, but on an Azure confidential virtual machine, running with AMD confidential CPUs and an Nvidia H100 confidential GPU. The pod that will run this model server will perform 3 steps. First of all, download the encrypted model. Then perform attestation on the CPU and the GPU, and then fetch the key from the Trustee operator to decrypt the model. Third, run the model with the GPU. First of all, we show that the runtime class of this model is kata remote. This means that this pod is running as a confidential container peer pods outside the worker node. This is also proved by the Azure Web UI, where we can see that there is an additional virtual machine with the same name as the Coco predictor that we just ran, running together with the worker and master nodes. And the instance size of this virtual machine is standard NCC 40 ADS H100. In Azure terminology, a C means confidential, and H100 stands for the H100 Nvidia GPU. From the Azure documentation, we can see how this type of instance is for confidential computing and provides an Nvidia H100 GPU together with AMD confidential computing CPUs. Let's now look at our predictor logs and see what happens. In the first step, we download the encrypted model and then perform attestation. First of all, we perform GPU attestation, and we can see that it was done successfully. Then we download the model. We can see that we only get an encrypted model from the S3 bucket storage. At this point, we perform attestation on the CPU using the Trustee operator, and we get a key from the operator. Then we use the key to decrypt the model using the same program that we used on training. And now we can see here that we got a decrypted model. And then we extract the folder, and then we run the model as if it was a normal one. In the Trustee logs, we can see when the call was made. It performed a lot of steps that cover the whole attestation stack. And the main log we can see is resource access requested passes the policy check, which means attestation was successful, and that's why we got the key back. Let's look at the last step when we run the actual model. We can see here that the same script that detects if there is a CPU or GPU, this time wrote CUDA, which means it detected a GPU. Therefore, this model runs on a confidential container with an Nvidia H100 confidential GPU. Let's now compare the two model servers. Let's start first with runC. Just as a reminder, runC model server is a traditional Openshift AI pod. It runs on the worker node, and the worker node doesn't have any GPU. The script that we will run the models is always the same. It requests the same question to the model an infinite amount of times and counts how many times the answer was provided. Let's run the runC model first. We can see that the model answers, but it's very slow because it's only using the CPUs. Now let's switch to the Coco model server. As a reminder, the Coco model server runs on a confidential container that contains also an Nvidia H100 confidential GPU. Let's run it and see what happens. We can see that the Coco model server is much faster than the traditional runC model because it's also using GPUs. And to conclude, in this demo, we have shown you how OpenShift confidential containers work, what is a confidential container, and what is a confidential virtual machine. How we can extend an OpenShift AI workload with confidential containers to make sure data is safe also during execution. How confidential containers also support Nvidia confidential GPUs to securely improve AI performance. This concludes our demo. Thank you and goodbye.